the thing that we are discussing, that is the physical structure or geographical structure of a network. How the network looks after connecting all the devices through some medium wire or wired connection, how the network looks. The basic network topology that we used is called the mesh topology, where each and every device is connected with other devices. Now, what are the advantages? The main advantage is you can easily send your data to other device. Fault isolation is very easy. There is a guarantee data will be transmitted. It is faster because there is a point-to-point direct connection, dedicated link. But the problem is, the main problem is, with the increase of number of devices, the network size, the overhead of the network. What are the overheads of a network? The communication wire connection. Those are the overhead of a network. So in case of mesh topology, since it is a connected graph, so if there are n number of devices and you want to connect them with each other, then you need NC2 number of links. It means n into n minus 1 by 2 number of links. So with the increase of size or with the increase of number of devices, the network size will also increase, and after some times it becomes very difficult. Now see why it is very difficult. I'm giving another example why it is very difficult. Now see, more or less in our computer, when we are connecting with a particular device or another computer, there is something which will help us to connect two devices, and that particular hardware is called Nic card. I will show you in the labs class. So we have one Nic card, network interface card. Now normally in our network interface card, there is one jack point like this. The jack point will be like this, through which you can connect the cable. So if more than one device is connected with one single device, it means your network card should have more than one connection plug, which is not possible or not available. So that's why this mesh topology is good for connecting two devices. If in your mesh there are two devices, in your home there are two devices, you want to communicate these two devices, only two devices, then it is very easy. One device, one network interface card, one jack point, you are connecting with another network interface card with a cable. This is very easy. But if you want to connect more than one device with a single device, then your network interface card should have support. I mean, it should have more than one jack point. Logic clear? Why this is very difficult? So that's why the widely used network technology topology is a single backbone cable which is connecting different devices. A single backbone cable which is connecting different devices. It is look like that this is a road. This is a road. A bus is going through, and these are the bus stoppages. These are the bus stoppages where the person will go and person will come. So means data communication. So that's why this type of topology is called bus topology. Logic clear? Again, this type of bus topology having some problem. The main problem is, since we are using a single cable, single backbone through which we are transmitting the data, and remember, after some distance cover, the data will be, due to noise, the data will be, the power of the data, the power of the signal will be decreased. So in this type of channel, it is very difficult to transmit a data through a long distance. Clear? Next problem, suppose you are transmitting data from A to B, B is not receiving. Then where is the problem? To isolate the problem means problem isolation is very difficult. Okay, and sometimes when you are transmitting your data, that data is open to all. Why the data is open to all? Because you are using a single link, you are sharing a single link. You can say this type of configuration, you can say multiple access, multi-point, multiple access. One single cable media is used by multiple devices. So this is another problem in case of bus topology. Now the number 3, which we always use in our colleges and more or less in most of the networks are based on this, and this is called star topology. Okay, now star topology looks like this. There is a single device, communicating device, which is called hub or sometimes switch. What is the difference between these two? I will discuss about this in later classes. And then they are connected with different devices. The same configuration is used in our college. There is a hub. You in your lab, you will able to see there is a box installed above the ground, and there are different switches which is blinking always blinking. So this is called stack of switches. Okay, those switches are stacked configuration, means they are connected, they are also connected. So we have used this type of star topology configuration, and this star topology having a higher version which is called tree topology. So this switch is connected with another switch, this switch is connected with another switch, this switch having 1 or 2 devices. So this type of configuration is called tree. See, there is a center, then 2 branches or 2 or more branches. So this is called tree topology. So more or less there is mesh topology, bus topology, star topology. Instead star topology, there is a central device which will mainly control the communication. Okay, there is one version of this bus topology. When these 2 ends are connected in a bus topology, when these 2 ends are connected, it becomes ring topology. Now the advantage of ring topology is one signal will be circulated throughout the ring. In case of bus topology, if we send one signal, after reaching this end, it will be you can say stop. It will be destroyed. But in case of ring topology, the signal will be circulated again and again. Okay, so one version or variation of bus topology is ring topology. Similarly, there is another type of topology which is called hybrid, and I hope you will understand what is the meaning of hybrid. In hybrid network, there are different types of, suppose in one side of our college we are using star topology, in one side of our college we are using bus topology. So it means it is a combination of 2 or more topologies which is called hybrid topology. So these are the different you can say topologies or physical structures that we need to means if we want to create a network, we have to follow this type of topologies, and we have to follow this type of line configuration, transmission mode. So whenever we are going to create a network, we have to understand the things that what are the main components, number 1. Then we have to understand that the network should perform well. Then we have to understand how the network devices will connected, that is transmission mode, what are the configuration of the communication, how they are connected, that is line configuration, and what should be the physical structure of the network, that is the topology. Okay, so these are the main components or main things that we have to take care whenever we are creating a network. Now the most important thing that is, there are two devices, A and B. I've already discussed this. This one having Windows operating system, this one having Intel hardware, okay, and this one having Unix operating system, okay, this one having say Mac hardware. It means in these two devices, the hardware and software both are different. It means the understanding of the instruction is different for these two devices. It means this device only know Bengali and this device only know Tamil. And the question is how we can communicate, how these two devices can be communicated. Now there comes a very interesting thing. It means when we want to communicate these two devices, we don't know. When we are connecting two or more than two devices in a network, we have no idea whether these devices are of same type, same operating system, same, everything is same, we don't know. But we have to communicate. It means we need some open system. These two devices having different systems. Systems are different, correct? They are with different operating system, they are with different hardwares. So when they are trying to communicate, we need some open system. And that's why ANSI, then IEEE, they come with some rules and standards, and they develop the first thing that is called open system interconnection. It means, what is the meaning of this open system interconnection? The meaning is two devices with any hardware, any software can communicate through this network, through this channel, through this means communication protocol. So this is called OSI, Open System Interconnection. That is very important. So whenever we are trying to connecting two devices with different systems, different hardware, we need some open system interconnection configuration so that they can share their information. Otherwise, if one device only know Bengali, another device only know Tamil, it is very difficult to communicate. But we need to communicate, and that communication becomes very easier through this open system interconnection configuration. Okay, so this open system interconnection is, remember, is a kind of software which will help to interconnect. This is one kind of software which will help to interconnect two or more devices with different systems and hardware. Logic clear? So open system interconnection is a kind of software which will help two devices to communicate with having different software and different hardware. And this task cannot be done with a single system, with a single, means you can say single program. We need lots of programs to convert or to communicate between two devices. That's why this OSI will create a layers of programs, you can say, or softwares. That's why it is called OSI layer. Okay, so OSI layer is a kind of software which will help two devices with different hardware and software to communicate with each other. So the next thing that is very important, how these two devices can communicate. Okay. Now see, suppose this device having some data, it want to send A, comma B, then C. It want to transmit A, B, C to the device. So this is source device, this is destination device. Source device is trying to send the data to the, and the data is ABC. Okay. Now this data ABC is in character form, correct? So we have to convert it into binary form. Logic clear? So we need some technique to convert this to this. This technique is called translation. So we need to translate the data from its original value to binary value. Then suppose I want to transmit a picture, and we know that picture is required huge memory. Why? Because picture is represented in a form of pixel, and nowadays pixels having a huge size. One pixel having a huge size, it is considering, if it is a color image, it will store three different information: red, green, blue, and each and every red, green, blue having a value range from 0 to 255. So you can understand that one pixel means how much information. And nowadays we having 108 megapixel cameras. So if I want to send a one single image, then how much data I am sending, you can understand. Now, with the increase of size, it is obvious that the process of transmission will be slow. Because why? Because our channel, this medium, have a particular speed, transmission capacity, you can say, or transmission delay, means the time required to transmit a data. So when you are sending a huge data, it will take lots of time. That's why whenever you download an image, you will see it will be downloaded layer by layer. First it is hazy, then by time it becomes more sharper. When first you download, it will be a blur image, then time to time it will be increase, and then it becomes sharp. So it means whenever we are transmitting our data, if it is an image or huge data, we need to compress the data. That is very important. Compression, data compression. Otherwise, if I don't compress the data, it will take huge time to transmit a particular data. So what is the logic? We will compress the data. There are different compression techniques like JPG, okay, bitmap. Those are different compression technique. They will convert your binary data into some compressed data, and in the receiver end, it can be decompressed. So see, these things, this translation, compression, these are from sender side. In receiver end, it must be decompression, detranslation. This thing will be happening. Logic clear? Okay. So I need to translate my data from its original form to binary form. Then I have to compress the data. Okay. Then there comes another important thing. Nowadays, we will use this data communication to pass, to transmit our, to access our bank transactions. Correct? So when we are accessing our bank transaction, we are transmitting our password, correct? And these passwords must be you can say it should not be global. Whenever you are transmitting your password, see, whenever we are transmitting our data, nowadays we are transmitting our data through wireless media. It means there are data which are traveling in our local area. What we have to do? We have to understand. We have to understand what frequency we have to use to catch those data. That's all. If I able to catch the data with its particular frequency, then I can easily understand what is written in the data. So whenever we are transmitting our secure data, so we need to encrypt the data. Means encryption. We have to encrypt the data. Why we have to encrypt the data? It means we are trying to hide the information. We are trying to hide the information that we are sending. That is very important. So whenever we are transmitting a data, we have to take care of these three things. We have to translate, we have to compress the data, and then we have to encrypt the data. See, this is for sender side. In receiver end, what we have to do? We have to decrypt, we have to decompress, we have to retranslate. So this thing happens in the receiver end. To perform all these things, what are the things we are performing? We are performing number one, translation. I hope you understand translation from our original value to binary value. Then you have to compress. Why we need compression? Because I have to make our data the smallest possible size, so that it can be transmitted faster. Right? And I need to hide the data, so I will perform encryption. Now, anyone, can you tell me, should I perform encryption first, then compression, or should I perform compression first, then encryption? Anyone? Ovik, should I perform compression first, then encryption, or first encryption, then compression? Ovik Shah, are you there? No. Keshav, गोयल जी.
यस सर.
हाँ बोलिए, कौन सा काम पहले करना पड़ेगा?
सर पहले कंप्रेशन करेंगे तो सर इंक्रिप्शन के जब इंक्रिप्ट करेंगे उस डेटा को, तो कंप्रेशन के दौरान तो फाइल का साइज थोड़ा छोटा हो गया होगा ना?
तो पहले
तो
कंप्रेशन करेंगे.
हाँ, पहले कंप्रेशन फिर इंक्रिप्शन.
एनी और कोई जो इनसे डिफर करते हैं? पहले इंक्रिप्शन करेंगे फिर कंप्रेशन करेंगे, या फिर गोयल जी सही बोले? पलक,
Yes, sir. First compression, then encryption.
Why?
Sir, because I think the size of the file will reduce, so the encryption will be faster.
Very good. Thank you very much. First, you have to compress, so that in case of encryption, we are having is the smallest possible size of data. So it will take less time to encrypt. That's why first you have to compress, then we have to encrypt. Now remember, this is for sender side. Remember this thing. Whatever I am telling, it is from sender side. In receiver side, so in sender side, the sequence of performance or sequence of operation is first translation, then compression, then encryption. In receiver side, it should be what?
Decryption, extraction, and then translation.
लॉजिक क्लियर, समझ में आ गया? क्योंकि उस साइड में पहले हमको क्या करना है, जो एनक्रिप्टेड डेटा आया है उसको हमको डिक्रिप्ट करेंगे, फिर इसको डिकम्प्रेस करेंगे, ओरिजिनल डेटा में कन्वर्ट करेंगे, फिर उसको रिट्रांसलेट करके हम लोग बाइनरी से ओरिजिनल जो एनसी कोड या फिर जो भी है उसमें कन्वर्ट करेंगे. सो रिसीवर एंड में ऑलवेज इट शुड बी इन रिवर्स दिस वे. Okay, so we need one particular software to do these things. Okay, and this particular software layer is called presentation. Why this is called presentation? This is called presentation layer. Why this is called presentation layer? Because this layer is presenting our data, whatever I am writing. Suppose I am writing a letter. But first I have written respected sir, then the body of the letter, and then yours faithfully. Okay. So whatever I am writing in this letter, it should be converted to a presentable form. It should be converted to a presentable form to the network. It should be converted to a presentable form to the network. That's why this layer is called presentation layer. It is presenting our data into such form so that we can easily transmit it. Logic clear? So we need one layer, one particular layer. See, I have already told this is called Osi layer. This is called Osi layer. Layer means a set of softwares, step by step, sequentially. So first thing that we have to do these things. Okay. Now after this, what is the next thing? See, so if I do a pictorial representation, so this is my data ABC. First translation, it becomes like this: 110 1110. Then compression, it becomes 1010. Clear? Then it is encrypted, it becomes 0111. Logic clear? So now it is in presentable form. Now I can transmit it. Now before transmission, what are the most important thing that we have to do? The most important thing when we send some letter to someone else, we should have to include the addresses. That is very important. We have to add the addresses. So what are the different type of addresses available in case of computer communication? That is very, very important. Addressing or addresses. Okay, so 10 minutes left. Let's see how much I can cover. So now the very important thing, what are the different addressings? Number one, I hope you know this, IP address. Okay. Number two, that is very important, MAC address. And number three, that is also very important, that is called port address. So we need three different types of addresses, and three different types of addresses having different configurations, different style representation. So we need three different layers to do this. So after this data will passes through this layer. So we need three different layers to do this. Okay, we need one layer which will provide us the source IP address and the destination IP address. We need another layer which will provide us the source MAC address, destination MAC address. We need another layer which will provide us source port address, destination port address. Now, just a brief idea, what is IP address? We already know that IP address is like a form of this. 192.168.30.8. So this is one IP address. Now what is the meaning of this IP address? This is called global recognition, global representation. Okay. Now what is the meaning of MAC address? MAC address in the form of hexadecimal 0A:AB like this. Okay. And this is called local representation. And the port address means port address, it is in a form of 20, 30 like this. Okay. And this is the address of the program or software running. Logic clear? HTTP having a different IP address, sorry, port address. FTP having a different port address. So these are the three different addresses. Why these three addresses? See, global means, global representation means, suppose this take, sorry, so take, where is Mr. Suppose Keshav, Keshav?
Yes sir.
हाँ केशव, आपको घर में कौन सा नाम से बुलाते हैं?
आकाश.
आकाश. तो देखिए इसका मतलब
Yes sir.
you have two different representation, two different recognition. One is local recognition,
Yes, sir.
which is Akash, and another is Keshav, which is global. Similarly, for a particular device, it should have two different addresses. One is for global recognition, another is local recognition. So this IP address will give you global recognition, and this MAC address will give you local recognition. Why? Why this local and global things are coming? Because this is a local network which is called local area network, LAN. In this LAN, there are different devices connected. Okay, there is a switch which will connect all the devices. There is another network with a switch. This is LAN 1, this is LAN 2. Correct? There are different devices. So it may happen that this A device is connecting with device B. This A device is trying to send data to device B. Then will you require any global recognition? No, because this is inside the same network. So it will send the data through its MAC address. मतलब घर में आपको हर कोई आकाश करके बुलाने से आप आंसर दीजिएगा, ठीक है? लेकिन अगर कोई आपका फ्रेंड जो जिसको ये आकाश जो रहता है यहाँ पर, सपोज आपका फ्रेंड यहाँ पर रहता है, वो है एक्स, वो अगर आपको बुलाएगा तो कैसे बुलाएगा? वो तो आपको केशव बोल के ही बुलाएगा, क्योंकि उसको लोकल आपका जो आकाश नाम है वो मालूम नहीं है. So it means when X, which is in a different network, is trying to send a data to a device which belongs to another network, then it should be recognized through its IP address, because this X don't have idea about the local address. Local means it is local to a particular, it is jurisdiction under a particular pin code, particular network. But global means it is for all. So that's why two different addresses are very important. I have no idea when I am sending a data whether it belongs to same network or a different network. So I have to add both the addresses. I have to add the MAC address as well as the IP address. Now the next thing is the port address. Why this port address is important? Because it is like a, you can say it is like an electric port where a plug is connected. Through this plug, the data will be transmitted to the device or to the software. Suppose I am sending a data through HTTP. So that data should be connected or collected from a HTTP device. So that's why port address is very important. Why? Because in a computer, there are different software running. Different software are running. this is HTTP running, this is FTP running, this is telnet running. So different softwares are running. So when a device is connected through HTTP, it should be transmit the data to HTTP port. That's why we need port address. So these three different addresses are very important in case of data communication. So we have already discussed one layer, presentation layer, and then three different layers for addressing. Remember, this IP address is provided by one layer which is called network layer. The MAC address provided by one layer which is called data link layer. Okay, the port address which is provided by one layer which is called transport layer. Okay, so we have already seen presentation layer, transport layer, data link layer, network layer. Okay, now see, when I am sending, so this data, this is my original data, encrypted data. So with this data 0111, I will add the addresses. Source, say source port address, then destination port address. Clear? Then I will add source network address and destination network address. Then I will add source MAC address and destination MAC address. So all these addresses will be added. So now my data is like this. Now see, whenever you transmit, when you send some message to your friend, it sometimes happens that if your message is very huge, it is broken into parts. Am I clear? It is broken into parts. Part 1, part 2, it happens. And these two packets will be transmitted independently. And sometimes it also happened that part 2 received first, then part 1. But the sequence should be first part 1, then part 2. So depending on the capacity of the network, we have to break the data into smaller parts, and that is maintained by one layer which is called session layer. Okay, and then finally two devices must be physically connected, so we need another layer, physical layer. So how many layers we have already covered? Presentation, then session, then transport, then network, then data link, then physical, and we need at the top level one layer